Hello again, and welcome back to the Harvest Manager configuration series. In this chapter, we'll be taking a look at the configuration structure that most configurations in Harvest Manager follow. Before anything else, let's introduce ourselves to the hierarchical structure configuration in Harvest Manager. This configuration defines the weight assigned to a data field when a plot or cross record is being matched to config items. The level property in each entity defines the weight. The higher the value of the level, the more weight is given to the data field, increasing the chance that a plot or cross record is matched to a config item. This configuration has this abbrev in the database, HMConfig's hierarchical structure. Let's take a look at an example for this configuration. The hierarchical structure configuration is a JSON object with one property called entities. And this entities property is a JSON array, meaning it's an array containing JSON objects. Each JSON object defines an entity and assigns a level to that entity. In addition to that, it also defines fields that belong under that entity. For example, we have the harvest data entity in the first entity, and the level is set to 0. The included fields here are the harvest method abbrev, and number of plant. So what does the level mean in this scenario? The formula that we follow for calculating the weight of a given data field is as follows. It's calculated as 10 raised to the power of the level value for that particular data field. And again, the level is defined on the entity level. So for example, if the level is set to 0, like in this harvest data entity, we calculate the weight that will be given to the fields belonging to this entity by raising 10 to the power of 0, which is the level. And the final weight is 1. So every time that a plot or a cross record matches a field that belongs in this group, 1 point will be awarded to that config item. Similarly, if the level is 1, we calculate the weight as 10 raised to 1, which means that 10 is the weight or the number of points to be awarded to a config item if the plot or cross matches it. If the level is 2, then we calculate the weight as 10 raised to 2 equal to 100, and so on. So that's how we calculate the weight that we award to a given criteria or data field when we are matching plots or crosses to a configuration item. So let's take a look at the rest of the entities in this example hierarchical structure config. We also have germplasm, which includes the state, type, and generation fields. The level is set as 1. So the score or the weight given to these fields is equal to 10. Next, we have cross. Under the cross entity, we have the following fields. In particular, in this module, we'll be dealing a lot with the cross method abbrev field. The level is set to 2, which means that every time a plot or cross record matches any of these fields, 100 points will be awarded to that config item. Finally, we have the crop entity with just one field, which is the crop code, and the level value is equal to 4. This means that the weight given to the crop code is equal to 10 raised to the 4th power, which is 10,000. So every time a config matches the crop code with the plot or cross record, 10,000 points are awarded for that config item. So that's how the hierarchical structure configurations work in Harvest Manager. Later on, we will see some examples and some calculations on how this is actually being done in the back end of Harvest Manager. Just a note, the hierarchical structure config should not be modified without consulting the development team first. So please, if you need to make any modifications on this configuration, please do contact us first so that we can do some assessment and determine if the changes are plausible. With that said, let's now go to the main config structure. So here we have an example configuration. So each of the configurations in Harvest Manager are defined as like the following. Before I actually go to this sample configuration, I want to mention first the configs that actually conform with this structure. So the structure that we will be discussing in the next few minutes are applicable to the following configurations. We have the harvest data requirements config, harvest use case behavior config, and the harvest nomenclature configurations. So later on, we will also see this same structure as we discuss these configurations one by one in the next chapters. Going back to the sample config here, like I mentioned, the conforming configs all are defined as the following. All of them are JSON arrays. So as you can see here, we have an array here, and there are JSON objects within this array. And each JSON object within the array, the main array, is referred to as a config item. And each config item represents a use case. So for example, in this particular sample configuration, I have two config items. So this is the first one, and this is the second one. This means that in this particular configuration, I already have two use cases defined. And each config item in Harvest Manager have two main parts. The first part is the criteria. So this portion defines the actual criteria that a plot or cross record must meet to match with the config item. The fields mentioned in this portion are all referenced from the hierarchical structure configuration. So if we go to our samples again, we can see that we have these three properties here in this first config item. We have crop code equal to rise, cross method abbrev equal to selfing, and state not fixed. This means that this configuration item will match a plot or a cross if the plot or cross has the following information as well. The same is true for the other config item that we have in this sample config. So in the second one, we have crop code equal to rise, cross method abbrev equal to selfing, and state equal to fixed. After the criteria, the next part of the config item is the config. This is the actual config value, and its value varies depending on the type of config, which later on we will see as we discuss the other types of config in Harvest Manager. So if we go back to the example, the config is quite literally the config. So we have a property called config, and this is a JSON object. And within this config JSON object, we define the actual config value that will be applied to any plot or cross record that will match this config item. So this is the main config structure, and we will be seeing this quite a lot throughout this learning module in the other conforming configs. So for us to fully understand the config structure, let's try this exercise. Say I have this sample config over here. In this sample config, I have two config items. The first one, let's take a look at the criteria. So the criteria states that the crop code must be equal to Rice, cross method abbrev must be equal to selfing, and the state equal to not fixed. And in the second one, we have crop code equal to Rice, cross method abbrev equal to selfing, and state equal to fixed. So they're quite similar. The only difference is the state criterion. In the first sample config item A, the state is set to not fixed. So the plot or cross must have a state equal to not fixed. In the sample config B, the state is fixed. So that's the main difference between these two configurations. Aside from the sample configuration here, I also have this sample plot record. Let's take a look at the information on the plot record. So it contains the usual database IDs, such as plot database ID, experiment database ID, and so on. We also have crop name and crop code equal to Rice, cross method and cross method abbrev equal to selfing. And then we also have the germplasm information, which includes the designation, the parentage, the state, and the type. For this particular exercise, we will try to match this plot record to one of the config items in this sample config. And we will still be following the same hierarchical structure that we saw earlier. So let's keep that in mind. To help us visualize the config matching process, let's take a look at the following tables. Each table represents the score of each config item in our sample config. The first column is the criterion, which is the actual criteria that is defined within each config item. For example, in config A, as we've seen earlier, we have three criterion: crop code, cross method abbrev, and the state. We also added the level, which is based on the hierarchical structure config that we saw earlier. And then we have a side-by-side comparison of the defined value within the config item for each criterion, as well as the actual plot record value for that criterion. For each criterion, we'll take a look at the comparison between the config item and the plot record and determine if it's a match or not. And then we will calculate the cumulative score for each of the criterion and then come up with the final score for each config item. So let's start with sample config item A. In this sample config item, the criterion for crop code is defined as having the value of Rice. So now let's take a look at the plot record and see if it matches with the config item value for crop code. As you can see here, the config item is Rice and the plot record value for crop code is also Rice. This means that this is a match. So to denote that, let's just add this check emoji in this column. So before anything else, let's calculate the weight or the criterion score for this criterion. So again, we base this on the level. So in this case, we have level equal to 4. So we take 10 and raise it to the power of 4, which is equal to 10,000. So since this is a match, we'll be adding it to the cumulative score of this config item. So of course, we start with 0. Then we add 10,000 since the crop code of the config item and plot record value is a match. So at this point, we see that we already have a cumulative score of 10,000 for crop code. So let's continue to the next criterion, which is cross-method abrev. Looking at the config item value, we can see that the expected value is selfing. And looking at the plot record value, we also see that the value is selfing as well. So this again is a match. Now let's calculate the criterion score. So the level is equal to 2. We have 10 raised to 2, which is equal to 100. Since this is again a match, we will add it to the cumulative score. So we have 10,000 plus 100, bringing the total to 10,100. Easy enough, right? Now let's go to the last criterion in this config item, which is the state, or the germplasm state. In the config item, the state is defined as not fixed. However, the plot record has fixed as the value for state. So this unfortunately means that the value is not a match. So when the value is not a match, what do we do with the criterion score? So first, let's calculate the criterion score, 10 raised to level, which is 1, which is equal to 10. So as opposed to what we did earlier when the criteria matched, we added the criterion score to the cumulative score. But if it's not a match, then we take the criterion score and subtract it from the cumulative score. So in this case, you already have 10,100. But since this is not a match, we subtract the criterion score from the cumulative score. So we have 10,100 minus 10, which brings the total to 10,090. So that's it. We've ran out of criterion to test, and the final score for the config item A is 10,090. Later on, we will compare the scores of each of the config items in our sample config, and whichever has the highest score will be determined as the best fit config. So, let's take a look at the second table for sample config B. So we will be doing the same steps. First, we'll check if the config item value and the plot record value match. Then we calculate the criterion score and add it or subtract it from the cumulative score, depending if it's a match or not. So first, for crop code, we can see that both the config item and plot record has the same value, which is rice. So this is a match. Oops, sorry. Let's copy the correct emoji. So we have a match in this case. The criterion score, as we've seen earlier, is 10,000, which is the same as 10 raised to 4. And this will be added to our cumulative score. So 0 plus 10,000 equals 10,000. Up next, we have cross-method abrev. For this one, we can see that it's also a match, selfing, and selfing for the config item and plot record value. So it's a match, and we've already calculated the score for this, which is 100, and we'll just add it to the cumulative score, bringing the total currently to 10,100. Finally, for the state criterion, comparing the value for the config item and plot record, we can see that the value is the same, which is fixed. So unlike with the first config item, where it's not a match, not fixed versus fixed, this time we have a match. So we mark it like so, and we calculate the criterion score, which is 10 raised to 1, or equal to 10. And since this is a match, we will add 10 to the cumulative score, which is 10,100. So that's 10,100 plus 10 equal to 10,110. And that's it. We have the scores for both of our config items in our sample config. So now let's compare the final scores. Sample config A has a total score of 10,090, while sample config B has a score of 10,110. So based on the final score, it's clear that sample config item B is the winner. So this config in this case will be identified as the best matching config item for our sample plot. And that's how we match the configs with the plot or cross records in Harvest Manager. Again, as a reminder, we have what we've just seen, which is the config matching process, is applicable to the following configurations. So we have the harvest data requirements configuration, the harvest use case behavior configuration, and the harvest nomenclature configurations. So later on, we will see this exact same thing as we go to the other config types. Okay. So up next, let's try another exercise, but this time you will be doing the calculations. So before we go to the tables, let's take a look at our samples in this exercise. So in the next exercise, we have a new sample config. So let's take a look. So this sample config still has two config items. For the first config item, the criteria is crop code equal to rice, cross method abrev equal to selfing, and state equal to fixed. For the sample config item B, we have crop code equal to rice, cross method abrev equal to selfing, state equal to fixed, and there is an additional fourth criterion defined here, which is type, and the type should be equal to fixed line. So that is our sample config for this exercise. And we have this sample plot, which is the same sample plot that we had in the first exercise. So, and again, we have the same hierarchical structure config that we had in the first few examples. So now, what I want you to do is to pause the video and copy these tables, perhaps on a piece of paper or anywhere that you feel comfortable writing on. And then I want you to fill in the missing table values and then identify which configuration item is the best match for the sample plot record based on the final scores of each config item. So these tables already have the correct data based on the new samples that we have. So we have the criterion and then the levels, the config item values, plot record values. So now you need to determine if it's a match, calculate the criterion score, and then calculate the cumulative score. Once you have the final score for both sample configs, you will then compare them and determine which is the best fit for the sample plot record that we have. So at this point, you may now pause the video and do your calculations. Alright, so I hope you're done with your tables. So now let's take a look at the solution for this exercise. So following our process earlier, you should come up with this the same output as with these tables. So for the sample config A, we can see that all of the criterion were matched by the plot record. So we just have to tally the total criterion score, which is 10,000 plus 100 plus 10, bringing the total for total score for the first config item to 10,110. For config B, it's the same thing, and we can see that all of the criterion are also matched by this plot record. The difference here is that there is an additional criterion, germplasm type, and the plot also matched that one. So now we take the criterion score and add it up to get the final score. So we have 10,000 plus 100 plus 10 plus 10, bringing the total to 10,120. Comparing the final scores, the first config item has 10,110 and the second one has 10,120. And since config B has the highest score, then it is identified as the best fit configuration for our sample plot. So if you got the answer correct, great job. You now understand how configurations are matched to plots or cross records in Harvest Manager. And then finally, let's have another exercise, but this time I want you to write the criteria for a config item with the following criteria. So for this one, we want the crop code to be equal to maize, the cross method abrev equal to selfing, the state equal to fixed, or sorry, not fixed, and the type is landrace. So again, you may pause the video at this point and try to fill in the criteria portion in this sample config item based on this criteria. So you can now pause the video and come back later. Alright, let's take a look at the correct answer for this exercise. So again, we have the following criteria: crop code maize, cross method abrev selfing, state not fixed, type landrace. So the correct answer for this exercise would be the following. So simply put, we just add each of the criterion here above the config and specify the correct value. So we have maize for crop code, selfing for cross method abrev, not fixed for state, and landrace for type. And that's it for this chapter. In the next chapter, we will learn about the harvest data requirements configuration and how we can use it to define the relevant harvest data for a given use case.